You understand. Okay, an equal sign indicates that the value of the expression on the left is equivalent to the value of the expression on the right. This is essentially a way of saying we've got equal values on each side of the equal sign. Algebraic equation is two algebraic expressions whose values are equivalent to one another and which are connected by an equal sign. So x plus 2, if I'm saying that's equivalent to 7, then I'm connecting with an equal sign. So that's an algebraic equation. To maintain equivalence of the equation, what is done to one side of the equation must be done to the other side of the equation. Equations are like little kids. What you do to one side, you must do to the other side. Give one kid a cookie, you give the other kid a cookie. Equations are like balanced scales. To keep the balance, you do the same thing to each side of the scale. Okay. And the things we can do to an equation, we can add the same quality to both sides, we can subtract the same quality from both sides, we can multiply both sides by the same quality, and we can divide both sides by the same quantity. We can do some other things, but we'll start with these. I don't think we're going to get into raising both sides to a power or something in here. That's for the college algebra. Okay, so just in the essence of time, I'm going to actually run through these as written up here so that I'm saving time by not writing. So start out with an equation, and it says to solve for x. Find out what value of x would make this equation true. If you make it be an equation, it would be true. And as we talked about earlier, if I'm trying to isolate x, I'm going to get the loose connections away first and then the tight connections. Loose connections are connected by addition or subtraction. Right here I don't actually have any tight connections because tight connections are multiplication or division. So I'm going to do my addition or subtraction first. So I look up here, I said, well, I've got x plus 2 equals 7, I need to get the 2 away. It's being added, so I'm going to do the opposite of addition, which is subtraction. So I'll subtract 2 from both sides of my equation. And sometimes people like to actually draw a little line down from the equals to keep track of what's both sides. So I take away 2 from both sides, I get x plus 2 minus 2 is 0. So I don't have to write plus 0. Just, x equals 7 minus 2 is 5. Oh, so x equals 5, and then you just want to check. That's the neat thing about equations. You can check to make sure you didn't make a mistake in there. So to check, you take your original equation, but where there was an x, you plug in what you said x equaled. So we get 5 plus 2 equals 7. And yes, 5 plus 2 does equal 7. So that's true, which means that we didn't make a mistake. So our answer is that x equals 5. Okay. Let me know if you have any questions. Okay, so we got our next one. We want to solve this is slightly more complicated. X minus 2 equals 5 plus 3. And actually, I gave you an algorithm. Actually, I gave you a couple algorithms. I gave you this handout. One that starts with algorithm for solving equations in one variable. And this includes everything it covers in the chapter on solving equations, so there's more to it than we are right now. So I have an algorithm there. Below that is word and formula problems, so we'll advise on solving word problems. We'll read that in a minute. On the back of this is another algorithm for solving equations in one variable. It's just a structured algorithm. Does the same exact thing as the first one, but in this one, it doesn't leave you any options. It just says, do it this way. Boom, 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 boom. Whereas the other one, you get to make some choices. You still accomplish the same thing, but the second one, for those who don't like to make choices, you can follow it. Now the disadvantage of not making choices is sometimes it makes you do things ways that aren't maybe the easiest for you. But it all works out the same. And then lastly is the mathematics blueprint for solving problems. from your book. And the only reason I put it there is it shows up in one of your homework questions and you're going to what? Gather the facts, assign the variable, basic formula or equation, key points to remember. That's really about word problems. I just combine these things on one sheet. Okay, so if I looked at my structured algorithm, it would tell me to simplify each side of the equation. If fractions exist, I don't have any, so I can skip 1a. Go to 1b, it says, follow primitives to simplify each side of the equation. Oh, I can do that. X minus 2 can't simplify, but 5 plus 3 I can simplify. I know that 5 plus 3 is 8. So now I simplify both sides of the equation. I have x minus 2 equals 8. Combine like terms on each side of the equation. Oh, well, they're kind of one and the same. Did that. So now I'm at 2. Write all subtraction as addition of the opposite. Oh, I didn't actually do that here because I was using the unstructured. Well, when structured, I'd write it as x plus a negative 2 equals 8. Then, now that all subtraction is written as addition of the opposite, now it says use subtraction to get all the variable terms on one side of the equation. Remember that subtraction of a negative is addition of a positive. Okay. Also says use subtraction to get all of the constants to the right side. Wait, use subtraction to get all the variables to the left side. Use subtraction to get all the constants to the right side. And let's just kind of be together. So in other words, I want to get my variable on the left and my numbers on the right. My constants on the right. So this is a constant. So it says to use subtraction to move the constant. So I'm going to subtract my negative 2 from both sides. Of course, subtracting a negative 2 is adding a positive 2. So I get x plus a negative 2 plus a positive 2 is 0. X equals 8 plus 2 is 10, so x equals 10. And I've actually solved it at that point, so I don't even need to go through step 5. Finally, check the solution using Viet's substitution in the original problem. So let's see, this gave me x equals 10. Well, I did it slightly differently up here because I didn't use the structured when I used the unstructured. It says use addition and subtraction to get the variables on one side and the constants on the other. It even lets you choose which side. But in this case, I kept x to the left. I said I need to get this 2 out of here. I have subtracting 2, so to undo that I would add 2. So I added 2 to both sides, got x equals 10, that's great. Then we can substitute 10 back in for x. We'll get 10 minus 2 equals 5 plus 3. 10 minus 2 is 8, 5 plus 3 is 8, 8 equals 8. So yes, we have the right answer, and the answer is x equals 10. Okay. Over here. Now we got some fractions, and I didn't actually follow the advice on the algorithm because in my notes this comes before I ever get to where they talk about it. So I just skipped the bit about fractions and just worked it without getting rid of them. But here I need to get x on one side and constants on the other. I'm adding a half. To undo that, I would subtract a half. So I'll subtract half from both sides. Plus a half minus a half is 0, so I just have the x. Then 3 halves minus a half gives me 2 halves. Of course, 2 halves equal 1, so I'll have x equals 1, or 2 over 2. And I can check that, and I chose to check it by putting the 2 over 2 form in because I got everything in with the denominator to 2. So if x is 2 over 2, and add a half to it, I do in fact get 3 over 2. So yes, my answer is correct that x is 2 over 2, or actually it's 1. It's a form of 1. Because 2 over 2 is a form of 1. Okay. So now we, yes, go ahead.
The second equation, where did you get the 2 from when you plus 2 on both sides?
Yeah, okay. I said I need to get this constant, the subtraction of 2, out of here. I want just x on this side. So the 2 is being subtracted right there. So, well, if I have x and I subtract 2, but I just want to get x by itself, how would I undo subtraction of 2? Oh, I would add 2. So I add 2 to both sides because minus 2 plus 2, because the net change is 0, which leaves me with just my x. So I'm trying to get this number out of here so I have x on the side by itself. I look at how this 2 is connected, it's being subtracted. I do the opposite operation, which is addition. And I can't just do it on one side, I have to do it on the other side also. And so that's how I got that. Make sense? Okay, good.